Hello there, welcome. My name is Jonathan Panzer, and I started Eureka Tutoring, and I thought for the 4th of July we could do a little problem about fireworks and the physics behind them. So let's take a look at the problem. It'll be really quick, and maybe it'll help you. Okay, so we've got a firework here that's being launched from the ground at an angle of 75 degrees at a rate of 70 meters per second. Our V naught here is 70 meters per second. And it's going to explode at its apex at the very top, and we need to figure out what the height is where it explodes. So there's two things we need to know about the physics of this problem to be able to do it. Three things we need to be able to understand. The first is that at its apex, its vertical velocity, so Vy, equals 0. So its Vy at its apex is going to equal 0 meters per second. It just kind of suspended in the air right before gravity pulls it back down. The other thing we need to know is that, and I guess this ties into Vy, is that our V naught here is not just a vertical velocity. It's actually angled a little bit at 75 degrees. So what that means is that our V naught here, V naught can be broken up into a Vy component and a Vx component right there. So and how we figure out what Vy is and V naught is, well, we have to use a little bit of trigonometry, just a little bit here, and all we need to know is that the sine is the opposite of the hypotenuse, if you're familiar with SOHCAHTOA, right here. So we got SOHCAHTOA. We're going to use this one, and we see that sine is opposite over hypotenuse, so we're going to take the sine of that. So we're going to say V naught times the sine of 75 degrees, which is our angle, equals our Vy. And we know that V naught is 70, so we're going to have 70 meters per second times the sine of 75 degrees, and we're just going to do that really quick. So that is going to be 67.6 meters per second equals our initial Vy. So this is right when it launches out. That's what its Y velocity. Okay. The other thing we need to deal with is we have to pick an equation. So in physics, we have a lot of equations. We have to discern which one is the right one. So we take a look at our list here, and I have a list of common kinematic equations to figure out which one would be the most useful. Because oftentimes you can actually do these problems with more than one equation or more than one way, but one is normally the easier way. So taking a look at this, I have to look at what variables I have and what variables I don't have, and what I want to find. So here I don't have anything about time, so I'm probably going to avoid equations that have t in it, and that looks like all of them except this fourth one. And here I'm going to see, yeah, I have initial velocity in the y direction right here, and I know what my final y velocity should be, and I know the acceleration, because that's just going to be gravity, and I want to know this delta x, or in our case delta y. So I'm going to use this fourth equation. So we're going to set that up to be solved for delta y in this case. So I'll just write it out really quick here. So we've got our v squared, or our v final, equals v naught squared plus 2a, and I'll use delta y here. We're going to solve for delta y, so we're going to bring v naught squared over, so we're going to have v squared minus v naught squared, and then we are going to set that equal to 2a delta y. We're going to divide by 2a. We're going to get v minus v naught, and those are both squared there. Those are divided by 2a equals our delta y. Okay, let's plug in our values and let's see what we get. So our v final is going to be 0 squared. We're going to subtract our 67.6 meters per second from that, and we're going to square that. Then we're going to divide by 2, and our a value in this case is negative 9.8 meters per second meters per second squared. Okay, and that's going to equal our delta y. So if we solve that, we get, in this case, we get a value of, let's see here, delta y equals 233 meters. So that's our h right there. And now we know that's how we would do a kinematics equation. Thanks for watching. I hope you have a great 4th of July, and maybe you'll think a little bit about physics when you see the fireworks go off. Okay.